If there's one thing you get out of this video, it'll probably be that I can't draw trains to save my life. But hopefully what you get out of this video is how to solve an overtake problem. I've got two trains heading towards each other. The first train, the blue train, is going to be moving at 10 meters per second. It's going to start at a position of 0. We're going to define this as 0. And the other train is going to be 2,000 meters away. So this guy is 2,000 meters away. All right? These are our starting positions, so we need to make these x naught. Red train is going to be moving at a velocity, initial velocity, of, let's say, 15 meters per second. And we're going to give both of them a low acceleration. We're going to give red train, let's say, I don't know, 5 meters per second squared. I said low acceleration, but that's a pretty relative term. Let's give this one a 2 meters per second squared. Great. And this guy's moving in this direction. What I want to know is, at what position will they meet? They're going to hit sometime probably over here, considering the red train is moving faster and accelerating faster. But how can we figure out an exact location? Well, let's start by really defining these variable lists. Let's do the blue one first. I've got x, x naught, v naught, v, I'm going to move down here, a, and t. And then the red guy is going to be at x, x naught, v naught, v, a, and t. Now, I want to put in my variables that I've defined. Blue starts at 0, with an initial velocity of 10 meters per second, and an acceleration of 2 meters per second squared. It is accelerating in the same direction that it's traveling. Now, the red train, it's also going to have a final displacement unknown. Its initial displacement is going to be 2,000, but it's traveling towards 0. It's traveling towards the blue train. That's very important. So my frame of reference means that its velocity is a negative 15 meters per second. And its acceleration will be a negative 5 meters per second squared. So if I want to figure out where do these two meet, what I'm really asking is, at what number will x equal x? Well, it just so happens that I have an x equals x naught plus v naught t plus 1/2 at squared for both of these objects. And so since blue x equals red x, I can say this whole equation will equal this whole equation. And so I can write that out. So let's do that. And then let's get rid of any zeros, which x naught is a 0. And then v naught t, that's going to be 10t, plus 1/2 of 2 is going to be 1. So we'll just drop that. It'll be t squared. Then on my right side, my x naught will be 2,000, plus v naught t, which is negative 15t, plus 1/2 of a, which negative 5, that'll be negative 2.5 t squared. Now I can rearrange this and get my t's on the same side, and I'll have myself a quadratic formula. Let's do that by subtracting 10t from both sides and subtracting t squared from both sides. And I will end up with 0 equals 2,000 plus negative 25t plus negative 3.5t squared. And I can put that in my quad form, and I will find the time. And when I do that, I get time to equal 20.5 seconds. So I can plug that now into either of these equations. I'm going to plug it into the blue one because that looks easier to solve. So I'm just going to put 20.5 in for both of these times. Okay? And I will get a displacement 625.25. I say 6, I said 6. Okay. And now I could even check this by plugging it into this equation over here. Let's try that. So 2,000 plus negative 15 times 20.5 plus 1/2 of negative 5 is 20.5 squared. That gives me an extremely close value of 641. How different are these two values? Well, they are 2.5% different. 2.5% off. Ha! And if we forgive my horrible rounding, my time should have been 20.6. 20.6. And when I do that, I get a final displacement of 630 for both of these. Great. So this is what we call an overtake problem, where we have two objects that are moving relative to each other. I don't have to have my objects moving towards each other either. Let's do another example that is slightly different. In this example, I'm going to have a cop, and I'm just going to draw a box just for time's sake. This cop is watching traffic, and as that cop is watching traffic, someone's speeding at 65 meters per second. This would be close to 120 miles per hour, speeds past the cop. The cop immediately begins to accelerate at 2 meters per second squared. I want to know how far away, how much distance does the cop finally catch that speedster? So the speedster acceleration is going to be 0. We're going to stay at 65 meters per second. The cop is starting at v0 equals 0. Okay? So we're going to set up two variable lists. Once again, x, x0, v0, v, a, and t. Both of them start at 0 because they're starting in the same spot. The cop's initial velocity is 0 meters per second. So this is the cop. This is the speeder. The speeder is starting at 65 meters per second, but is not speeding up. 0 for an acceleration. And the cop has a 2 meters per second for an acceleration. So let's set up our problem. We've got the final placement of the cop will be equal to the final displacement of the speeder. And so we can set up both of these formulas. x0 plus v0 t plus 1/2 at squared equals x0 plus v0 t plus 1/2 at squared. We just set these equal to each other, get rid of our zeros. Gotta be 0, gotta be 0, gotta be 0, gotta be 0. And then we plug in our values. We've got 1/2 of 2t squared equals 65t. So let's move this guy over here. So we're going to subtract 1t squared from both sides, and we end up with 0 equals 65t plus t squared. So let's find that. I misspoke. This should be negative t squared. But when we do that right, I get 65 seconds. Excellent. Very straightforward. And so my time is going to be 65 seconds, and I can plug that into this equation. So it's going to be 65 seconds at 65 meters per second, and that's going to be 4,225 meters at a position of 4,225 meters. Let's check that with the cop car. So it's going to be 65 squared times 1/2 of 2, which is 1. And we get, once again, 4,225 meters. So there we go. So this is how we do overtake problems. We're going to set up two variable lists, one for each object that is in motion. We're going to define the motion of both of those objects, and then we're going to set their displacement equations equal to one another, find the time, then plug that time back into either or equation. And that will give us a final position for our overtake.